Hello, hello. Welcome back to the keys to AWS optimization. Well, we are going to be discussing how to optimize Bedrock. Yes, of course, we're diving into the world of AI as everybody is at the moment. I was actually at the London Summit yesterday, and I think 90% of the talks are about AI. Even the talk that I did was about AI, and I can always share a link on how to get access to that. But I'm excited to bring in two guests today. One you'll recognize, Adam from our team, who has become the AI guy in FinOps when it comes to optics, and David Tepper, who is from PayEye, who we had an interesting chat a while ago, and I was like, David is a proper expert when it comes into the world of generative AI, and he's going to be here to make sure we don't say anything ridiculous when it comes to this topic and keep us on track. Before we get into the episode, let's do our fun question this week, which is, have we had a frugal week or a splurgy week? Adam, why don't you kick us off?
Yeah, happy to. My week has definitely been splurgy. I had a lot of travel last week for both work and personal. So I went to Seattle for work to similarly do another AI presentation. And then over the weekend, traveled down to Miami for a family birthday. So all those things result in just a much more splurgy week than usual.
Nice though. I got to get and to plug in between here, I know Adams just mentioned his presentation. We are going to be presenting at FinOpsX about some AI stuff as well. So if you're going there, you'll see it. But we'll come back to FinOpsX in a bit. But David, what about you? A splurgy week or a frugal week?
I've had a splurgy week in maybe the nerdiest way possible. So,
Oh,
uh,
my favorite.
yeah, sitting down at my computer, not going anywhere, not even so much as buying food from outside of the house, but I've been using so many AI coding agents to get stuff done that it's racking up like a giant bill in that way. And so it's splurgy,
Oh.
but it's really cool because I get to see all this awesome stuff start to come out of it.
I love that. That's the kind of stuff, and that's why using is that using stuff in your normal life, or is that using it for work that you're just
We use it a ton at PayEye, but also I have a side project right now that's like in the last hour when I can barely keep my eyes open. I'm like, maybe I can get this done, and like without the coding assistance, when I'm that tired, I wouldn't be able to do it at all. So yeah,
I love that. There's it's that kind of like I must keep going mentality when it comes to technology. I know what you mean. I had a relatively frugal, I'll say, because I went to I was just saying to these guys, I went to the London Summit. Say I met a couple of people. Thank you so much for coming up to me and saying hi. Really appreciated meeting some fans of the show. And I did not get that much swag. I got this cool shirt that says artificially intelligent and a hat. That's basically it. So, but if I don't know if that's frugal or spurgy, but neither. But a thing you mentioned is one thing that another Adam, suggested is I get some of those NFC, I think that's the right letters, cards where you can like program it to have your LinkedIn. So bought a bunch of those and I like set it up and set them up for people. So that was quite fun. But I spent, like you said, David, into the night. I was like, I should do this right now, even though it was like really late at night, and I just decided to spend time doing it. Very silly. Anyway, let's get on with it. So, welcome everyone to the Keys to AWS Optimization, the show we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Steph Gooch. I'm a senior SA advocate. I feel like I got my title right the first time, which I hadn't done in ages. And I am here to help you with all of your FinOps questions and journey. I'm bringing in these lovely guests. Adam, do you want to intro yourself?
Sure. Adam Richter, a solutions architect on the optics team. So I work with customers exclusively doing optimization, governance, FinOps, and as Steph pointed out, more recently, a lot of that has been around AI, ML. And
Brilliant.
David, you want to both introduce yourself and maybe give us 1 minute origin story?
yeah, absolutely. So I'm David Tepper. I'm the CEO of PayEye. Oh, 1 minute origin story, I like that. Back in my day, no. So I was with Microsoft for about 19 years. I've been in the Gen AI space for a very long time. My first patent in Gen AI was back in 2011. So well before transformer architecture and sort of the big wave, I was working on some of the technologies that led to that. While I was at Microsoft, I was giving a bunch of talks to the executives there about how they should be thinking about Gen AI. I represented Microsoft in speaking about Gen AI to other Fortune 500 companies, to universities, and at one point to the US Congress. 2 months ago, I was flown out by the United Nations to go talk about how Gen AI is going to impact developing island states over there. I've been giving talks about Gen AI to several, like, like Stanford, FIU, things like that. And so I've been in this space, for years. It was this cool side fun thing while I was doing, the tech of the day, which was mostly cloud and things like that. and then it just exploded, as we all know. And so now all of that knowledge, I hopefully can bring to the limelight and share with great folks on this call. So it's great.
You can see why we brought David on. He knows his stuff. But don't worry if you're sitting there thinking, oh, I don't know, Gen AI in the Stanford level of knowledge. The reason why we did this episode is we've got these three different kind of personas on. So we have David, who is like the deep technical expert and knows it really, really well. You've got Adam, who is the FinOps expert and has now moved into this Gen AI space to combine the two. And then you've got me, who you all know is not the strongest Gen AI person. I will take my certification soon, but at the moment, I'm definitely going to be hopefully your mouthpiece for this episode, asking the questions to dive into the topic. But we're going to try and take you with us. We're going to explain a bunch of the terminology, how to break these things down, and things that you should be thinking about and asking questions when it comes to you developing your FinOps practice with Gen AI in mind. Let's get into some Amazon Bedrock. We've actually got a point, which is meet Bedrock. How do I optimize Bedrock? I think that's the vibe at the moment, right? We're constantly using AI to ask about optimizing. So let's get into some questions and prompts. Let me start with a maybe simple question, but a question that hadn't occurred to me until recently. David, what's the difference between AI ML and Gen AI?
Yeah. Well, uh, AI ML, it's funny because machine learning was called ML for the longest time. And then from like a marketing standpoint, people are like, oh, it's artificial intelligence. Like ML traditionally is it's little more than statistical learning, right? Which means that you provide a whole bunch of data and then you build a model of that data. And then you can say, hey, if I were to provide new data that was similar, how does that statistically model out a similar enough answer, right? And so you can kind of model behaviors and so on. Um, in reality, Gen AI is not any different than that. It's still built on the same fundamental principles. However, we have invented a series of systems that are still statistical models, but they seem to have the capability to reason. And they have the ability to produce unexpected or new results, even given the same input data that they were originally trained with. And that seems to have triggered this shift to calling it AI, right? And so there's almost a distinguishing line between it's machine learning if you're not using any of these new mechanisms that introduce reasoning or introduce the ability to sort of extrapolate beyond its training data. And it's generative AI if it's capable of generating something new given the same level of inputs, or inputs that it was not originally trained on.
Okay, yeah. That makes sense. And so, Adam, when it comes to FinOps, how should we be reframing? Should they be thinking of this as two separate things, or can we relate a lot of the same concepts and mechanisms together with these two different sets of terminology?
Yeah, I think you could think of them together from a cost perspective, but I guess one part that kind of gets confusing in the industry is like, are we using AI in FinOps? Or are we using FinOps for AI? So like, are we trying to figure out the costs or how are these technologies being used? And one thing that came to mind while David was like explaining the difference, and maybe it's a good example to think about when you're using AWS is like AI ML is used in our anomaly detection product. So that's analyzing past data, it's looking for potential anomalies in future data, and it can alert you. Great, right? Whereas generative AI is this creating new information or new data. So that's in things like Bedrock is something you can use that for. Or from a cost perspective, when you're running things out there, whether it's, an analysis or something generative, like we're probably going to think about a lot of these costs together.
Mhm. Okay, makes sense. So let me do something simple to get us all in the same kind of mindset and level set. David, I have three super quick questions and super quick answers, hopefully. I want to go cover some different terminology elements. So these are three things I feel like I hear a lot in the world of Gen AI. So what are they and why do we care about them? Okay. The first one I hear a lot of is FMs.
Uh,
Then, yeah, do that one
Go
first.
ahead. You want to give me all three, and then I can just run
Yeah.
through them.
Yeah. So FMs, LLMs, and tokens are the three I hear a lot.
Gotcha. Cool. So FM can actually stand for two things. There's foundational model, which are models that are in the same family. And so everyone's heard of a GPT, so like GPT-3, GPT-4, and Llama, if you've heard of those. Like those are examples of foundational models. And I think that's what the one you're referring to when you say that. And then there's also frontier models is the other FM acronym. And that refers to the state of the art models that are coming out. All the AI labs are pushing the state of the art, and they call that's our frontier model across the board. So you might hear it in that context as well. LLM stands for large language model, and it is basically this type of reasoning model that I referred to earlier. It's really the cornerstone of Gen AI. It's what sparked this huge AI conversation across the world. And it's a way of simply saying that we are taking uh, almost all the text that exists on the public internet and training a model that can handle that amount of language and can understand language deeply and in a nuanced fashion in the same way that humans can, so that you can then talk to it in a natural language way and receive natural language answers back. And so that type of model is a large language model. And then tokens are actually the sort of unit of language that those large language models operate on. And so they are parts of speech. Sometimes it's a word like the word the, if it's very, very common. Other times it could just be a portion of words, right? And it's really an optimization mechanism of how large language models think about language. They have to break it down into smaller chunks and then construct words out of those tokens. And so tokens are also the billable unit for the majority of large language model utilization as well. And so we'll talk more about that, I'm sure.
I feel smarter already. When it comes to that, the token, just drilling into that a little bit more, where is it defined what a token size is? Is that depending per model or where you kind of host things? How is that decision made?
All right, we're going to get a little bit more technical here, right? Language models, AI models in general, don't operate based on based on letters. They operate based on numbers. It's math. It's statistical modeling at the end of the day, right? And so that means that in order for them to, if you ask it a question in let's say English, it has to actually convert that back down into a mathematical representation so that it can do a bunch of math so that it can then output a bunch of numbers, which then get reconverted back into an English language sentence that I can understand. And what the tokens are is they represent the mathematical relationship between words. And so I'll give you an example. Let's imagine that I had the word king, and let's say that that was a token for the sake of the conversation. If I converted that into its mathematical representation, I would get a giant vector of very, very large numbers. We have thousands and thousands of numbers to represent that word. And those numbers are not random. Those numbers actually represent the word king's relationship to all of the other words that that model is trained on. And so then if I take the word male, for example, and I convert that to numbers and I subtract king minus male, I'll end up with a bunch of numbers that are very similar to the word queen. And those numbers are related to each other in thousands and thousands and thousands of dimensions, way more ways than the human mind can think of. And those are the things that constitute the tokens. It's actually the vector representations of the relationship between words. And by understanding that and by being able to manipulate that, that is actually the means by which these large language models can reason.
Uh, I feel like I just stunned. I was like so engaged in listening. I hope everyone enjoyed that in the chat because this is the this is why the reason why I wanted to talk about it is because I am brave enough to say I didn't know what it was, and now we all know. But that was a really good explanation. For a minute when you said male, I thought you meant
Like
most.
male, yeah, like
Yeah.
packaged mail, right? Yeah.
Show me love. And just two things in the chat before I want to jump into a bedrock, which I'm going to throw to Adam. Just a thing, initialism, not an acronym, is FM. Just as FYI. Someone has said so. When it spells a word, it's an acronym, but when it's the initials, it's an initialism. And Steph, no background. Well, I could always switch to a virtual background if I wanted to. I actually have this one, which is oh no, that's my static background. Apparently, I can't change while I'm live, but I have a virtual background of this one, but it's going to take up too much bandwidth.
When you don't know why your
Well,
background's
there we go. That's my old background. I'm now in a virtual background, but it's just of my background. You can see the slight changing in my lighting. But while I change back to my old one, Adam, there's also we've heard David, thank you for explaining all those things, and now to like specify into more of the Amazon world, Bedrock. This is something that is a managed services we have, but do you want to give us a brief overview of what Bedrock actually is?
Yeah, happy to. So, Bedrock is our managed AI service. So when you're thinking about deploying AI in your organization, you have different choices. You could go with self-managed, which would be launching EC2 instances. And in those scenarios, that's where you have to have a team with like data scientists, AI engineers, and folks that are going to be actually like launching the models, configuring them, doing the training. There's a lot of cost and lift potentially behind that, but it gives you full control of the whole training process. And in those cases, a lot of the billing is around like per hours of instances and things along those lines. To make all that easier, Amazon made Bedrock, which is our managed service, where you don't have to go launch or think about or worry about any of that underlying infrastructure. You can instead log in, pick the models that you want to deploy, and then interact with it very simply using an API. And because of that, that's where kind of touching back on the token thing we just talked about, you're no longer having to think about billing like per hours and things along those lines. It's billed just words in, words out, which roughly translate to tokens. And it makes that a lot simpler. So when I think tokens get kind of a weird, perspective in the industry right now because they're new and not understood. But for all of us that have been doing FinOps for a while, it's really no different than something like Lambda, right? It's a serverless. It bills like per second of use. And tokens are kind of the equivalent of that in this Bedrock or AI space where it's words kind of going in and out. So that's the main like kind of gist of what Bedrock is. There's a lot of power to it though. Like there's guardrails, security stuff, privacy stuff. There's a lot of things built in that can make it really easy so that organizations can just focus on building and deploying something of business value rather than under all that underlying management.
Yeah. And if anyone wants to learn a little more, I'm going to plug as well. Check back in the earlier to see the link, or on the YouTube channel, you'll see the link to the video. I talk a lot about the guardrails and stuff that protects us. So when it comes to choosing between Bedrock and doing it yourself, I guess the main thing is if you have people that are trained on how to do it right, that's the kind of, it makes it easier for you to do. It's the simple thing. Is it
It
that?
does make it easier for you to do, and then it also makes it easier for you to stay up with like the models that are changing. Because when a new model comes out, which they do often, right? We see alerts of different things like DeepSeek and our Nova Pro and Llama recently came out with Maverick 4. In Bedrock, it's really easy to make that change. It's just one line of code and you can be using the new model in your setup. Whereas if you're, on-prem, it may not be one line of code anymore. You may have to retrain some stuff and do a lot of work to get that deployed. So from a speed perspective and like agility to be able to use new models, it's really powerful there. One of the things that impressed me most about the Nova models was the speed. I started using Nova Pro as one of the models that answered. And not only was it like thorough, but it came back with really fast answers. So if any of you out there, in your organizations haven't tried it yet or are thinking about it, it's definitely worth experimenting with.
Yeah, that we prompted it yesterday, Aaron and I, and we were like, tell a story about the friends Aaron and Steph who go exploring about happy orange clouds, something crazy. And it wrote like a full page in seconds. And it was kind of astounding how fast that is. Anyway, we're getting off topic. Let's dive back in to some things talking about the pricing of these models that we're talking about, which is a good kind of segue. Um, Adam, when we talk about the different ways it's priced, there is things like on demand, off demand, provisioned. Can you just give us a quick overview of, I mean, you kind of did already, but like anything else we need to know when it comes to how these pricing models, how to price for models in Bedrock?
Yeah, so it does go by token, as I mentioned, and the pricing does vary depending on the model that you select. And there are three different ways to kind of slice and dice the pricing. You can either do on demand, which you're just paying per use, kind of like I mentioned with like Llama being an equivalent earlier. So in that case, you're really just paying per batch of tokens. It's like per batches of 1,000 tokens in and out. So those are billed separately, the tokens going in versus the tokens being output. So that's one option. Great option if you just need real time. You're going to have maybe variable like input and output, so you don't have predictability in how much is running. If you do have predictability in how much is coming in and out, then it may make sense to consider provisioned. So with that, instead of paying kind of per use or per token, you're paying per time instead. And it goes, per an hourly bill, and you commit to a 1 or 6 month. So in our minds, in our kind of FinOps minds here, think about this as the equivalent to commitments like savings plans in our eyes. Doesn't work exactly the same and you get shorter terms, but it's a way to get both capacity and cost benefits by being able to commit over a certain period of times. And then lastly is batch. So if you don't need any kind of real-time response, if you just want to be able to run something kind of offline. Maybe it's a large data processing. It's if you want to test a new model that you're not currently using, batch is great because you can kind of run that asynchronously and separately from what you would normally be running. And it's oftentimes 50% or so cheaper than if you were to run that test on demand. So that's a great way to test. And I encourage a lot of folks out there, like when these new models are coming out, go test against the new model using batch. At least you'll get a good idea if maybe this model's better than what you're currently using, especially if you're not sure if you want to use it on demand yet. So that's a good kind of tidbit to get out there and try that particular billing type to see if it could benefit you.
Yeah, awesome. And I wanted to kind of dive into the models, not necessarily the models themselves, because talking about them is kind of irrelevant for us specifically, but how to decide, or at least because the people who are probably watching this are not going to be the people who are choosing a model, right? They're not going to be the ones who are going to be diving in and making that selection. But if they needed, if a if a developer was like, I need to start choosing models to start using, and they want to think about trade offs between different styles, David, what's some advice about kind of comparing models and how do they know which is the best one to choose rather than it's like when you Google like for shopping, the first one that comes up isn't necessarily the right one. How do they make a more educated decision?
Yeah, I mean, that's a whole field of study to choose the exact model. The way that I would think about it is that new models are coming out constantly, and they're always really pushing this state of the art, right? So to the frontier, as we were talking about earlier. And so the correct model is less a statement about any one individual model, and it's more about the following. So firstly, you need to make sure that your enterprise can actually make use of that model, right? And that means that, you've got all the data privacy stuff sorted. If you're using Bedrock and your company's already using AWS, you're set there. You don't have to worry about going through InfoSec for a whole bunch of other potential model hosts. And then I would really think about models in terms of three different categories. You've got your super, super cheap model, which is used primarily for classification. So that means that if you wanted to make a decision between A or B, or pick out of a smallish list of things, given a description for each in some kind of a question, right? That's where you can use a super cheap model. Something like Amazon Nova Micro is really good at that. It'll give you, a choice out of that list. You're not asking it to reason. You're not asking it to like interact with a user directly. Really, it's more for kind of either back officey style things or just as a component of your existing code. If you want to take a step up on a cheaper model, DeepSeek R1 also very good at this. So it's going to be a much more powerful model than Nova Micro. It's significantly more expensive as well, but it's still very, very cheap. And it's still something that would be really, really good at making these types of classification decisions. Then your next category is your workhorse model. And so that's your model that's going to be doing the majority of either the interaction with the end user or a bunch of the larger tasks that you've got that are part of your Gen AI application. And my recommendation for that right now through Bedrock is Claude 3.7 Sonnet. That's released by Anthropic. That model is just fantastic across the board. It's really good at writing code. It's really good at creative writing. It's really good at interacting with users, just understanding, of emotions and how to interact with people. It's just fantastic at that. And then your third category of model is your reasoning model. And that's if you wanted to tackle really hard problems, tackle big data, where it doesn't necessarily have such an obvious solution, or it's not meant for direct interaction in real time with an end user because the reasoning can take a while. So if you have a pipeline or workflow that's running in the background and you needed to chug through significant amounts of data and increase the accuracy at the expense both of time and money, then go with a reasoning model. And for that, on Bedrock, I would still recommend Claude 3.7, but it has a thinking option. And so you can enable thinking. When you enable thinking for Claude 3.7, you can specify a budget and a number of tokens that you allow it to think for. There's a minimum of 2048, and I would recommend a maximum of 32,768, right? Those are the ranges that I would keep it within. And those would be the three categories and how I would think about it.
Okay, cool. I like that kind of breakdown into these different ones so that, and for you guys watching, like I said, if anyone ever asks, like, "Oh, I don't know where to start," you have these ones and comparing the cost. And the pricing page on Amazon Bedrock does give you a lot of information. You can see how those work. And if you want to start with these choices and then test around, um, Adam, when it comes to types of models, when we choose all these different ones, whether it's Llama or Nova and all these funny buzzwords, how do they actually show up in the Kerr or Cost Explorer?
Yeah, and I think that's often overlooked and important to understand because if you were to go to Cost Explorer Kerr and just filter for Bedrock, you'd actually be missing part of the costs inadvertently. So by default, the models are split into, you could think of them as like native or integrated models and third party or marketplace models. And there's a benefit to that, right? That the native ones, you can just go log into your Bedrock console, you can pick them, deploy, and you're ready to go. Third party models, there's a marketplace where other vendors can provide models that can be used inside of Bedrock, and they're built in more of the fashion of like marketplace. So because of that, depending on the model that is being used inside your organization, if they're using the native one, it'll show up under Amazon Bedrock in both Cost Explorer and Incur. If they're picking one of the third-party models, though, it's actually going to show up in as a marketplace charge. So it's the billing entity, AWS Marketplace, instead of just AWS. And then things like the product code. So if you're creating queries and doing that kind of stuff, the product code for the stuff that's integrated or native will just show Amazon Bedrock. The product code for things that are third party are going to have like a marketplace ID. So it'll be like a longer, kind of more cryptic number. So it's important to just make that distinguishment and kind of add those together when you're looking at your total marketplace costs, because you want to be able to probably understand them in aggregate and not in the pieces. And the biggest mistake I see is folks will just go in and just pick Bedrock, and then they'll miss all those third-party marketplace charges.
Yeah, that's something, and I remember when I used to do things like chargeback back in the day, that I feel like we would have certain filters on for marketplaces, like dealing with them in different places, especially because we didn't use it that heavily, and so it was gone off to a different cost center. So be very mindful. So
Mm.
let me just double check that. Is that right? If it's something that's an Amazon-owned model, it will come up as Bedrock, and if it's one of the other ones, for example, Anthropic or something like that, it will come as
Nope.
Mark. Oh, no.
Close, close.
Just
Um,
okay, do
so
me again.
if it's one of the natively integrated ones, so the ones that Amazon has
Oh.
built-in support for, so like David mentioned, right? Like Claude 3 Sonnet 3.7, that's
Yeah,
built in natively. You can just go in there and
okay.
pick it. Same with some of the Llama models, of course, the Nova ones. So any of those are going to be like natively supported, the ones that you'll see also on the pricing page. Those will all show up under Bedrock. Now, if you go, there's a marketplace inside of there that you can pick from hundreds of other models that are not, the big kind of ones that you see built in, and those will show up under marketplace charges.
Okay, I should edit out me being dumb. And then
No, it was a good question because other folks probably have that same thing, and it's important to understand when you're going in to quantify this stuff.
yeah, it's the association. And does it, as a drill down question, to double check, if you do choose something that is, does it distinguish between in care that you chose Nova or that you chose Claude?
Yeah. So in the ARN and if you're picking marketplace as well in other fields, it will show the actual model that was picked. And then even in the usage line items, it'll oftentimes have kind of an abbreviated version of what the model is, dash input or dash output for if it's the input or output related cost. So it gets pretty granular, and you can definitely slice and dice down to exactly which portion of the cost is most relevant for you.
Yeah, I feel maybe an update to my code talker, FinOps X. Maybe we do a little bit of a deep dive talking about some of this stuff might be a good idea. But we'll see. Yeah, let us know in the chat, FinOps X. And also let us know in the chat. Do you have any questions? Anything you want us to deep dive into? Let us know. So before we move on to some other optimization techniques, evaluations. So how do we know we're doing a good job? Uh, David, do you want to give us a summary of like what we should look for when it comes to things like evaluating a model?
Yeah, sure. So those are two separate things, and I just want to make sure we're clear on that. So there's evaluating a model, which is making the decision about which model to use and is it right for my use case, and I can actually start there. And then there's also the term eval or doing evaluations of the model as it's running in production. So let me start at the first part, which is I'm evaluating a bunch of different models. I'm trying to figure out which is the one I should be using for my use case. The types of things you should be thinking about there should be things like latency, availability, throughput, primarily, and I'll talk about those. So availability is more than just uptime and sort of whether or not it's going to be present and alive. Bedrock handles that extremely well. Obviously, the AWS cloud is alive and well most of the time, and so there's no big issues there. But it's also is the model available in the regions or locales that I want to make use of it? And it may be available, but there might not be any available capacity. And that's because right now the whole world is trying to do as much as they can with AI. And so there's very limited capacity for a bunch of these things. And so going back to Adam's earlier points about provisioned capacity versus on demand, if you're using on demand, you'll actually be able to hit a really broad set of capabilities instead of GPUs, because the on-demand actually just tends to blend across a variety of different regions. When you're provisioning capacity, you're paying up front to get capacity in a specific location, and that might not be available. And so if you want to use it, if you want to use a particular model, you have to make sure that it's available for your needs in the place that you want to go after it. The second is throughput, where okay, it's available, but for my particular use cases, I'm going to be running thousands of requests a minute, millions and millions of tokens through this thing. Is the amount of capacity that's available to me capable of meeting that workload? Right. I probably don't want to go through the complexity, at least in the beginning, to have several different models that are hosted in different locations that are handling different portions of my traffic. And so you really need to make sure that, again, if you're provisioning capacity, that you're provisioning enough to handle all of the different requests per minute and tokens per minute that you may be able to use. And there's also the speed of the model as well, which really bleeds into latency. And so latency for generative AI is a bit more complicated than like traditional cloud. There's 4 different latency measures, 5 if you squint, more so than just the one which is really common, which is end-to-end latency. So I made a request to this service, it gives me back a result. That's end-to-end latency. That's the same thing as in cloud, no new differences there. In Gen AI, though, with specifically LLMs, you've got time to first token as the second one, which is basically I'm going to ask a question of this model, and how long does it take to come back to me before it starts to give me a response. So this is really important if you're streaming the tokens, because that's when the user starts to get a feedback that something is actually happening, right? That it's heard of their request and it starts to come back. Fun fact about time to first token, as it pertains to the third one, which is inter-token latency, which is the time between tokens, is that most of the time when you ask an LLM a question, it has solved that question before it returns the very first token. And the way that you can kind of prove this to yourself is imagine you had a maze, and that maze had multiple inputs and outputs, and you asked it, hey, find the shortest path through that maze. If the first token that it reports is along the wrong path, then it cannot give you the correct answer. And so it actually has to solve the maze before it returns the first token to say, this is the beginning of the shortest path through the maze, right?
Oh.
That's that's why the time to first token is often an order of magnitude slower than the inter-token latency, which is again the third one. The fourth one is output tokens per second, which is really a function of inter-token latency. It's just really how fast is this thing moving, and that's more a function of for your use cases, how quickly does it need to finish what it's doing, and really get out the get the answer out to the end user. And then the very last one is for reasoning models, which is time to first completion token. So let's go back to that maze example. I asked the question to a regular model, and I asked a non-reasoning model, say, Amazon Nova, right? And then I ask it to a reasoning model like Claude 3.7 Sonnet with thinking. They will both return back with their first tokens relatively quickly. But the first token from the thinking model will be reasoning about the maze. It will be attempting it from a bunch of different angles. It won't be locked into that same decision of I have to do it on the very first token. And so it will reason for some amount, and then it will give you the first token that's actually usable as part of the completion, as part of its result, right? And so you have this much larger gap, even though it's streaming and even though the time to first token came back more quickly. And so those are all of the trade-offs to consider as part of evaluating which model to choose. The
Mhm.
the next part of eval, the risk of being long-winded, is this catch-all term for making sure that your Gen AI-powered solutions are functioning as expected, either as a test bed or once you've deployed them and how they're doing in the wild. And so the nature of Gen AI is that it's highly probabilistic, right? Every single time you use it, you're going to get a subtly different answer. And that's a core part of its value in the first place. And so you really don't want that to go away. And so no matter how much you test it locally, when you've got a bunch of users that are interacting with it, they're putting in new data, they're asking you questions you haven't thought to ask it, it's going to behave differently in production. And so you need mechanisms to verify what it's doing, and whether it's what it's doing is exactly what you're expecting. And so evaluation is this huge emerging field, and there's a lot of different techniques and mechanisms to go about it. One of the most common techniques is LLM as a judge. And Steph, I'll pass it over to you. I know this is something you know about.
Yeah, so one thing I'll just quickly plug on LM Judge is it's a very simple thing to kind of get started. What it does is it will use pre-trained models to evaluate yours, but based on a set of decisions that you put in, and it will provide you with some test results, and it can provide it in either in a human-like response, which is kind of handy, especially like we're saying, if you don't have a data scientist to run these tests for you. One reason that I like bringing it up is it has responsible AI metrics, which is a responsible AI is a whole other topic. But one thing is that you can have stereotyping, I think refusal and harmfulness, and you can start to test for those along with a lot of other of the things that are way past this call. But I think it's something that people should start looking into, especially if they want to start checking how things are doing and they don't have someone in-house who is an expert. So it's something that's a handy thing that we can kind of take advantage of. So I want to dive into a couple of questions. One of them is, that one. Can you train a model on normal cost data and use it to find cost anomalies? So I would just say rather than spend the time training a model and doing all this, you could just use anomaly detection. I'm sure hypothetically we can do this, right? But if you want to just have anomalies, I would just use cost anomaly detection. But does that sound like a smart
And it's
answer,
free.
Adam? And
Yeah,
it's free.
it's free, right, to use that. You can tune it in there as well, like pick your thresholds for alerts. If you want to get a little more advanced, you could also pipe your cost data into QuickSight, and there's some like AI anomaly detection features you can use in there.
Yeah.
But obviously, yeah, worst case, if you really want to go down the road of building it yourself, you could. I personally don't love AI's ability to understand math unless you do a really good job of like tagging all the fields and having it understand the relations really well. So I would say trust but verify if you're doing it yourself.
Look,
Make sure that what it's giving you isn't a confident hallucination.
Can I just jump in on
found
that?
the t-shirt. Yeah, of course, David.
Yeah. So it is it's almost like using a blast furnace to bake a potato. Um, the size of a model that does traditional like mathematical anomaly detection is very very small. They're very fast and they're very accurate because they're focused on just that. This is back to your earlier AIML question. Like that is a machine learning task through and through. You're statistically learning patterns, and then you are detecting those patterns. One really funny Easter egg, which I'm not sure was intentional on behalf of the Amazon team, was that Amazon Nova is ANOVA, which is analysis of variances, which is a really common anomaly detection technique. Um, and so I don't know if I was intentional or not, but that's like a precursor to traditional AIML. Using a large language model to operate directly, not on math, but on numbers. And I'll distinguish those things because math is really about the relationship between variables. The numbers are the tools by which we sort of exercise that, particularly as humans. If you're using an LLM to understand numbers, they're very bad at that because numbers are also just tokens. And so it's thinking about the numbers as it relates to other words, not as it relates in a mathematical context. And so you're going to get these, as Adam called them, confident hallucinations. It's not the right tool for the job.
Oh, interesting. Okay. Thank you for the questions, guys. Keep them coming. There's one more actually I just want to mention as well, which is any thoughts on when Nova Act will be available outside of the US? I don't have not privy to that information, but what I would do is let your account team know that you would like it, and then you can also raise a product feature request, and that is the best way for us to know what customers would like. Let's move on. Now, we promised we've already discussed some kind of choices around how it looks in the news report and choices around models, but I want to, in the next kind of 20 minutes, I want to run through some high level optimization opportunities that people can start to look at if anybody sitting there in a FinOps team is getting a message saying, you need to optimize Bedrock now. You can start thinking about some of these concepts and at least advising people to look into them. So, what we'll do is I'll throw a concept I've heard about to Adam. Adam can kind of summarize it, and then David, if you have any kind of things you want to add to it from a technical point of view, let's do it that way. But let's be quick fire, not quick fire, super fast, but relatively. So, Adam, distillation. I've heard this is a way I can optimize. What is that, and how does it work?
Yep. So distillation was announced within Bedrock at reInvent last year. What it lets you do is take a large model, use that in conjunction with your data and some questions to train a smaller model so that the output of that is a smaller model that you can use that is finally in a way kind of optimized for the type of data and questions that you're getting. And then you can just use that smaller model going forward. The benefits here are that the distilled model oftentimes is 5 times faster and about 75% less expensive. But I know David has some, I feel like some nuances about what that can show up like, um, in the hallucination potentially or in the quality of the data. So I would definitely be curious to hear what his thoughts are there as well.
Yeah, model distillation is really great if you've got a very scoped task. You're basically taking imagine you've got a huge brain, right? And that brain knows about like everything under the sun and it's like super intelligent. But you're like, I only really care about soccer, right? Like that's like the only thing that I care about in the whole wide world. And so you're almost like lobotomizing like that section of the brain and you're like transplanting it into a much smaller, easier to operate one. But a second you ask it about something that's not in that exact domain, it's gonna just lose its mind, right? And so if you have a very, very, very scoped set of scenarios where it will literally, it's not going to be taking generic input from an end user. It's not going to be trying to interpret highly diverse data. Anything like that will cause a distilled model to hallucinate vividly. We'll call it right, where it'll just outputting a bunch of garbage. But otherwise, it like Adam, you hit the nail on the head. It's way cheaper. It's way faster. Much smaller model. It's absolutely great optimization.
I think one way David summarized this in the past was it makes it better at some things and worse at others. I think that's a good
Mm.
takeaway for distillation.
Brilliant. What about fine tuning, Adam?
Yep. So fine tuning is a little different, right? You're using just a single model and you're giving it again, data parameters, different stuff to get more, I guess, out of that model. So you're taking it and slightly modifying it in a way to improve its performance, improve its output. But the considerations here you have to think about are, you need data to be able to train it. There's a cost to doing that fine tuning. Mind you, it's not like doing fine tuning if you were self-hosted, where you've got to have a lot of like that same knowledge to go in and configure and run the infrastructure. But then Bedrock, it's significantly easier. But there is, of course, a cost associated with it because now you're modifying a model to improve it, ideally for your use case. And the other thing to think about here is how often are you going to need to retrain it? Are you going to need to do continuous retraining? Are you going to need to do occasional retraining, depending on how your inputs, are modified over time? So it's a great way to take a model that you maybe like and make it a lot better at something within your domain, but it can, come with additional costs. That said, those costs can be a benefit, right? If your model is giving much better answers in the output, your customers may have to ask less questions, right? They may be able to come and ask one question to get their answer rather than 5 or 10. And that can have a net positive impact on your overall cost and the experience. And then, David, did you have any kind of additions on that?
Yeah, I mean, fine tuning is a continuous journey, right? Like we talked about,
Mhm.
where you're no longer extracting like a whole topic and trying to stuff it into a smaller model. You're now taking a model for your use case, and you're just trying to make it better and better at that use case over time. And so the likelihood that you're going to redistill a large model into a small model is much smaller than the likelihood that you're going to refine tune and you're going to continuously fine tune. And there's a lot of techniques for gathering the appropriate data and making sure that you've got the right sort of corpus of data to fine tune with. One important thing about both distillation and fine tuning is that once you create those models, they are your models. And Bedrock will not host them broadly for the world. And that also means that you have to then purchase provision capacity for them to run on. So they don't do shared capacity because it's not shared, it's just for you. So you're essentially creating your own custom models with the tools provided by Bedrock, and then you have to buy the hardware, rent the hardware that it's going to run on.
Interesting. Okay, so a lot of trade-offs when it comes to fine tuning. What about latency optimization, Adam?
So latency optimized is just a feature that can be used inside of the requests, and it can only be used for certain models. So the ones that are supported right now are Nova Pro, Claude 3.5, and then Llama 3.1. But what it does is instead of using those models in their native configuration, you can add in an optimized parameter and you'll actually get replies faster. So there's a slightly higher cost for using this optimized version of these models, but you get replies much quicker. So it's speed is a big factor in your organization, or kind of that time to getting a response. This can be highly valuable to enable. I wouldn't say it's not an optimization for cost, right? A lot of us with our FinOps hat on are like, how can we reduce the cost?
Yeah.
This is an optimization for performance, as we'll get much greater speed at a slight premium.
And I guess, wait, you're not paying, we're never paying for speed. We're not paying for speed. So for example, like with a Lambda function, if you've configured it wrong, it takes longer, that costs more. But with latency optimized, you're not going to get a cost benefit in the end by having that. It's just going to be that you're getting a fast output in total, right?
Yeah, so think about it as like if you were running something on a bigger server with more CPUs and more power, right? Like it's going to be able to do it a lot quicker than it would if you were running it on a smaller or slower server. So that's kind of the case here, right? You're saying, okay, I like these models, I like the output, but I need, like, speed is the most important here. So run this on the best and fastest hardware possible so I can get really, really quick answers. And that's what this kind of flag does. And then there's just like I said, premium for that.
Yeah. Anything to add on that, David?
Yeah, if you have a restricted amount of time that your LLM workflow needs to operate within, then purchasing additional speed actually lets you purchase additional reasoning effort as well. Because then you can crank up the amount of reasoning that the model can do in that amount of time, and then you'll, get better answers as a result of that. So it's expensive. You're choosing the premium route, but you're doing it for a much better user experience. And it's great that Bedrock offers that capability.
Okay. All right. I'm going to throw in the last quick one before we go on to something a little bit more technical. And that is prompt caching. Just as a quick shout out, I know it's a very specific use case for it, but Adam, quick summary on that.
Yep. So prompt caching, when a prompt or a question's asked to a model, that question goes to the model, it kind of processes, and then it returns an output. With prompt caching, when that's enabled, if you get the exact same question within 5 minutes, it won't have to go back to the model. It'll grab it out of its cache and give you an answer from there instead. So if you have a particular setup where you're getting a lot of like duplicate questions within a very short period of time, prompt caching can be, I think it could save around up to 90% costs, and also be much faster latency wise, because the answers will come out of a cache instead of having to go back to the model every time and then get all those, token processing and token requests. But right now, like the big kind of caveat in there is there's a short kind of that time to live, that caching time, and then there's very strict matching right now. So it's got to be that your use case has very repetitive questions happening within short periods of time. But if that is your use case, or if you know of like even a business unit inside of your environment that's doing something like that, then this could be a great solution for you to save a good bit.
Yeah. Anything else on that, David?
Is it on by default, Adam, or do they have to enable it?
No, it's not on by default.
That's good to know.
Or tick box. Okay, on to our last bit with our last 10 minutes remaining. I know, David, we wanted to talk a little bit about RAG. And I find it, what does it stand for? Because obviously RAG has a few, or RAG, there's a few different connotations of RAG, like we had the FM at the start. But in the worlds of Gen AI, what does it stand for?
Yeah, yeah. As opposed to cleaning rags, right? Which is not in the.
Oh, I meant like red, amber, gold, which is how, do you guys, which is like we use that as like RAG status a lot. It's like how well you're doing, like green, amber, wait, red, amber, wait, yeah, red, amber, green, not gold. I mean, anyway, David, go.
RAG in the Gen AI context stands for Retrieval Augmented Generation. And so the gen in Gen AI is generative, right? And so you're generating things. And so then the retrieval augmented part basically means that you're grabbing stuff from outside of the model's knowledge base and stuffing it into the context that the model is working with, so that it can then augment its generation with what you just retrieved, right? That's where that term comes from. And here's sort of a high level of it. When you train one of these AI models, they are a snapshot at a point in time. They know what they know based on the data that you stuffed into it. Again, it's not much more than a statistical representation of the data, and now some means to reason over it using the latest stuff. But there's going to be a combination of several reasons why it may not know about what it is you want it to know about. Like the very easiest and most obvious case is when it's new, right? So the model was trained back in 2024 and something just happened yesterday. There's no way that the model can actually know about that. It's just not in its original training data. Or the model is capable of understanding like all sorts of details about what's public on the internet, but doesn't know anything about your private specific data that might be specific to your company, specific to your enterprise, right? It's confidential. You don't want that out on the public internet, so it was never part of the training data in the first place. And so, in examples like that, you want to be able to grab data from other sources and pull it into the context that you're working with in the model, very similar to as if you were like chatting and you just typed in all of that stuff yourself, right? It would be the same kind of thing. And you want to be able to grab that and pull it in. And so that is the high level of RAG and what it's used for. I was
Okay.
going to go into way more detail on this.
We haven't. I wish we were another time, I think. The Adam, what when Dave was saying about pulling in that data, are there some native data sources in Amazon that people can put the data in to connect to easily when it comes to Bedrock?
Yeah, and inside of Bedrock, RAG is basically called knowledge bases, which knowledge bases let you connect in different types of data sources so that that data can be like indexed and referenced. Some of the types of sources that are supported are things like S3, so if you've got things kind of curated in a bucket, SharePoint, Salesforce, or even just web pages if you want it to go crawl web pages. The use cases for RAG are great when you need to augment your, with current data, like David said, or even domain specific stuff. So if you had like ticket data or product data or manuals or something unique to your organization, you could just point it at that data, have it index it, and then now it has that as part of its knowledge. So that's some of the data sources. The other element that kind of happens after you point it at a source is it indexes that data and supports it and puts it in a vector database. So that's a component that's sometimes overlooked with Bedrock when it comes to cost. So if you set up a knowledge base, and it will by default create an open search serverless, which is a separate cost. So again, if you filter for Bedrock, you're not going to see that cost. It's going to be over an open search serverless. Similarly, if there's an S3 bucket that it's reading data from, well, then there's that cost as well of reading those objects from that bucket and the storage cost of storing that data in that bucket. So understanding kind of your total cost of solutions is important because there can be related things like that.
Okay.
And there are a lot of, you don't have to use the native thing. You can kind of roll your own if you want to do your own vector database and connect it in. That's all possible with Bedrock as well.
And so when it comes to the cost of those knowledge bases, now you've said that, I remember when we talked about Optimate, what that is, because you've shown it to me before. And so classic us having to rebrand something or give it a different name, and I'm totally confused. So when it comes to those other data sets, sorry, is there a cost for doing that? Or is it just the
Yep.
cost of, for example, getting data from S3, but there's a cost for connecting it to Bedrock?
Great point. Yeah. So once you've decided to use a knowledge base, we'll stick with Bedrock terminology for now. The things that will impact the costs are twofold. There'll be the indexing costs, and then obviously the data storage cost, which I touched on. So if you have a bunch of objects in a bucket, you want to make sure that you're only having objects in that bucket that'll be relevant. You don't just want to throw a bunch of extra stuff in there because there's going to be a cost with it indexing and searching through that data that's in there. So if you give it a lot of excess, you're going to be scanning through all that and indexing all that, which will be unnecessary costs. So that goes into kind of the data component, kind of garbage in, garbage out, right? Hygiene is key here. You want to make sure that you're, removing data that's no longer relevant, only including data that is relevant. And then lastly, being careful not to edit or update files that are in your, say, S3 bucket, because if the file has changed in any way, it's going to be re-indexed by that the next time around that it looks at it. And then you'll be paying a cost again to index data that's already been indexed. So just be very careful on like how frequently you're indexing data and with how often that data changes. Looking at those two compared can really have a positive impact on your indexing costs if you're not having to index very frequently and if your data is not changing very frequently. I have seen customers that they just, kind of default are refreshing, once an hour, once a day, something like that. But then data's only being added once a week. So, think about trying to match your indexing frequency with whatever is, how your data's changing, I guess.
Yeah, There's a lot of things. I like the phrase garbage in, garbage out. The same, it kind of brings us back full circle to thinking about general FinOps that we know and love, which is if you have stuff that you're storing that you don't need, you're going to be paying for it. Why are you paying for stuff that you don't need? With that, we have like 2 more minutes, and I just wanted to pass to David because he's got this lovely PayI branding, and we haven't even touched on this of what PayI does. And as you might hear me say, PayI, PayAI, there's a bit of a pun in there, I think. But David, you're going to be at FinOpsX chatting about some of this, but give us a brief summary of what PayI do, as well as people know they can come and chat to you at FinOpsX.
Yeah, absolutely. So we'll have a booth at FinOpsX. At PayI, we transform Gen AI spend into business value. And so you can think about it as FinOps plus plus, specifically for generative AI. So we'll help you understand exactly where all that cost is coming from, help you associate that back to individual use cases, but more importantly, help you determine what the ROI is for all of that spend. What value are you getting as a result of you adopting AI to tackle particular use cases or objectives or, tasks throughout your organization. And we have really pulled together an all-star team to make PayI a reality. Most of us are, really big tech vets who have been in this space for a very long time. It's the world-class enterprise-grade observability platform and control platform for Gen AI across the board. And so if you want to understand your spend, control it, maximize your ROI on Bedrock, or otherwise, come to PayI. Check us out at FinOpsX. We'll be there talking with a whole bunch of folks.
And we'll make sure David's LinkedIn is in the video chat underneath when we share this. So make sure you check out his profile. And yeah, come see us at FinOpsX. Adam and I are going to be doing a talk on Gen AI optimization. We believe we're going to be chatting about that soon to get things ready. But don't worry, we'll be bringing you updates. That is it for us this episode. I saw there were some questions we didn't get to today, unfortunately. So if you have any follow-up questions, please email us at costoptimization@amazon.com. Make sure you give this video a like and subscribe to the channel to stay up to date with everything. And next week, we're going to be doing another AI topic. It's a bit of a theme this season. And we're going to be having a look at doing an Ask the Experts with some Amazonians about general concept. We're going to dive into a lot of different things, including stuff, as we guessed, stuff I don't know about. So any questions we need you to ask, otherwise I'll be the one asking. So join us there next week. From that has been it from Adam, David, and I, and we'll see you next week. Bye, everyone.